Okay, we might get started. Welcome everyone to the webinar today. Thank you for coming along. I'm very excited to have you and to present what we have. We'll be taking a look at permissioning today and how it's applied through Pantheon and how it's going to be useful to your enterprises. Presenting today, we have myself, Chris Mackay. I'm one of the protocol engineers working on Pantheon at PegaSys and primarily working on the permissioning implementation. And joining me today for the practical part of the webinar will be Lucas Saldana.
Hi everyone, I'm Lucas, working with Pantheon for maybe 1.5 years now, and happy to see you guys in the end for our demo.
So today we'll be going through what is permissioning in Ethereum and why it's important to the business use cases that you have. We'll be looking at how it's applied inside Pantheon and what are different mechanisms you have available to you. Let me run through a demo of how it's exercised, and then we'll be looking at some of our future plans for permissioning and what you can expect in the coming months and years. A few friendly reminders before we begin. Please keep yourselves muted so we don't have to battle with sound on this webinar. Please ask any questions you have in chat. We'll be stopping regularly to answer those questions and address anything any concerns that you have. We will have a longer Q&A session at the end where we'll be happy to discuss anything about the solution or anything about Pantheon for that matter. We will be recording this session, and after we are done, we'll be sending you the recording and the materials in an email. A little bit about PegaSys before we begin. PegaSys is the protocol engineering group at Consensus. We build the Pantheon client, amongst other things. PegaSys' mission is to build enterprise Ethereum, and we've done this through focusing on maintaining and scaling mainnet and lowering barriers to entry for enterprises. We've built several enterprise-grade features into our Ethereum client Pantheon to help lower these barriers for entry, and we've hosted prior webinars on 2 of Pantheon's other features, privacy and our consensus algorithm IBFT2. And we're excited to have you join us today for our webinar on permissioning. So, what is permissioning? In traditional Ethereum that we all know and love, permissioning doesn't exist. Everyone is allowed to join the Ethereum network. You're allowed to participate and do as you will with only the economic barriers of having the currency required to transfer to someone or being able to pay for execution on the network. There's no one who's going to require you to go through registration to join the network. There's no one who's going to require you to provide details about yourself. There's no one who's going to tell you that you're not allowed to do something. It's the wild west of computing and participation. And while that's excellent for a distributed worldwide system that we want wide-scale participation in, this makes it not suitable for every enterprise use case, where there are a number of reasons why enterprises may want to control who can participate in the chain or what actions they might be able to perform, and have requirements to control the communications that can occur on the network. So let's go through in a little more depth some of those reasons why enterprises do require permissioning. One of the first reasons we've encountered is that they require the ability to verify the identity of people who join their network, and they require a mechanism to prevent people from joining until they've gone through some sort of onboarding. Now, this onboarding might be to validate ID and recording details of state-provided IDs, or it might be to collect reference details for participants, such as their location in the world, or contact details such as phone numbers or email addresses. It might just be to populate attached systems that are living alongside the private Ethereum network. And you might need to go through these onboarding processes to satisfy regulatory requirements, or it might just be a domain requirement of your business that you have these details about the participants before they're allowed to interact with your business. The permissioning system gives you a mechanism for establishing this gateway that people will have to pass through before they can enter the network. Second major reason we've encountered is that there's a requirement to restrict accountabilities. On your private Ethereum network, it's quite likely that you want to restrict business that occurs on the network to business that is relevant to the consortium that's operating the network. And this might mean that you want to restrict the code that's deployed on the network and restrict deployment of that code to just administrators. you might want to limit the transfer of value on the network and restrict the amount that might be transferred in a single transaction, or throttle the activity on the network. You might have a requirement to suspend accounts when they've been temporarily compromised or when they're undergoing investigation. Say, for example, you're in a financial sector and a certain participant is undergoing SEC investigation and you're required to freeze their assets. This is a mechanism that allows you to restrict the usage of their accounts until these proceedings are concluded. And the third major reason that we've encountered is to limit the damage from bad actors. Contracts on the Ethereum networks, once deployed, are never editable. They become immutable objects, and whatever bugs might have been in the code, they're now there for the lifetime of the network. If these bugs are such that they involve a black hole into which ether can be swallowed, or perhaps create an attack vector for scammers to steal value through, it's likely that you're going to want to prevent your other customers on the network from being able to use these contracts and being able to damage themselves through interacting with them. Permissioning gives you a mechanism for blacklisting these contracts and blocking use of them in the future so that no further damage can come from their existence. And it's inevitable in any business case that someone is going to try and take advantage of the resources and the customers that you have inside of the network. Once you've identified these people, you definitely want to prevent their ability to take advantage of your legitimate customers. Permissioning, again, gives you the opportunity to block their access to the network and prevent further damage which they might incur. So before we proceed any further, I might pause for questions. Do we have anyone from the room?
Chris, it doesn't look like anyone has any questions at this time. I think you're free to keep moving.
Great. So we'll take a look at some of the types of permissioning that are offered inside Pantheon and some of the different facets which can be used. So first of all, we have local permissioning. This is permissioning that affects your individual node without affecting the rest of the network, and it's configured through locally stored files that are on the server that you're operating, and is influenceable at runtime through JSON RPC calls to your node. Typically, you're going to use this to restrict the usage of the node that you're operating, to restrict either resource usages or restrict the customers that are allowed to access your node and that you're facilitating. And it doesn't require facilitation of the rest of the network because all the configuration is local in files against your node. You can react to changing business conditions or to threats against the network immediately without coordination with the rest of the network and apply the rules locally to defend your node before having to interact with anyone else. So while it is immediately effective, it unfortunately can't affect future events on the chain. It can impact the resource usage of the node that you're operating, but because a majority of the network is not aware of the rules that you have installed on your node, you can't expect that new blocks that appear are going to be abiding by these rules. So local permissioning is purely about protecting your node and restricting usage of resources that are directly under your control. The other part of permissioning that accompanies this is the on-chain permissioning. This is a type of permissioning that is shared amongst all the nodes which are operating on the network, and all well-behaved nodes are expected to be abiding by the rules that are advertised in on-chain permissioning. It's orchestrated using smart contracts that are deployed to the network, and at runtime, these are influenced in the same way that you would normally interact with smart contracts by sending transactions to them. The restrictions which you advertise through these contracts, it's expected that all nodes on the networks will be abiding by them. And usually it requires some form of coordination with the remainder of the network to install new rules. The contracts which can be deployed are very customizable, and we'll get into that in a bit more depth later. But usually there will be some sort of administrative load, such as getting agreement from other parties involved in the chain or getting a quorum from an administrator's list to install new rules onto these contracts. So you may not immediately be able to react to threats, but when you do react, the entire network reacts as one to shut these threats down. And because these rules are now being advertised to the majority of the chain, you have more than 50% of the chain verifying that these rules should be abided by and making sure that new blocks are abiding by these rules. So you can expect things like suspended accounts to be reflected in new blocks on the chain and prevent them from having further influence on the chain. Looking a bit at the entities that we can control through permissioning. The first entity we've got is the nodes, the servers that make up the Ethereum network. And through node permissioning, we have the ability to control which servers can participate in the network primarily. And this gives you a mechanism to remove badly behaved servers, ones that constantly advertise bad blocks or might be recognized as repeatedly processing transactions that shouldn't have been allowed into the network. And it also gives you a mechanism for restricting participation to servers that are run by known identities. So you might have a reason for your consortium to only allow nodes where you have the contact details of the administrators that are running them, so that when faults do occur on the network, you have a fast method of recourse for getting in touch with all the operators so that you can make changes. The other entity that we tried that permissioning can be applied to is the accounts that are operating on the network. And this lets you control which accounts can participate and what they can do. This gives you the mechanism to enforce your onboarding requirements or identity gathering requirements. It gives you a mechanism to suspend accounts when they've been compromised or when they're under investigation. It lets you blacklist broken contracts when they've been identified as being dangerous to users. And it allows you to restrict actions that accounts can take, such as restricting who might be able to deploy contracts, or who might be able to call certain contracts on the network, or even who might be able to transfer value. At this point, it's good to discuss to some degree how permissioning differs from privacy and how they don't overlap. When talking about node permissioning and being able to restrict communications on the network, one of the questions that we usually encounter is, how can we use that to restrict people from accessing our network and accessing the data on the network? And unfortunately, you can't really use permissioning for that. Permissioning gives you a mechanism to stop people from being able to influence the chain and take actions against the ledger that's being stored. But it requires a distributed network of trust across the network. The only reason for people to follow the rules that are being advertised is that they've agreed to. A single malicious node can decide that they aren't going to follow the rules, and while the majority of the network is then going to prevent them from taking actions which add things to the ledger or change details on the ledger, it's not going to stop them from connecting to nodes which were banned from the network. And a single node can share the entire contents of the chain to the rest of the world, breaking any expectations of privacy. If you do wish for privacy on your private network, you need to rely on restricted privacy through a enclave device such as Orion, or through an on-chain mechanism such as ZK Snarks. So I'll pause at this point for more questions. I can see we've got a few in the chat. Grace, would you take us through them?
Yeah. I think we're going to wait on the first one for Joe, if you don't mind providing a little more context, and then we'll hop back. Second one is from Marcus. Is local permissioning based on accounts?
Local permissioning is based on both accounts and nodes. You can restrict which nodes you'll talk to and which accounts you will receive transactions from. So it can do both of the entities that we're trying to address.
Mm-hmm. And then how are the admins decided for local and on-chain permissioning?
For local permissioning, the admins are whoever has access to the server. It's controlled by files that are stored locally on the server or through JSON RPC access, and typically JSON RPC access for the administrative functions is locked down to local access as well. For on-chain permissioning, the admins are decided in a variety of ways. The contracts which are used to adjudicate on-chain permissioning are completely custom based on the network operators, and the administrative functions that are allowed can be custom based on the chain's requirements. We'll go a little later in the presentation into how the permission contracts that we have are currently doing administration. But the admins, we have scenarios where the admins could be decided by voting them in, or by endorsement by a quorum of organizations on a network, or through a super admin who has omnipresent control over the administration list.
Good answer. Next question we have is, node permissioning works like in quorum, meaning do you have a file where you have all valid nodes in the network?
Yes, for our local permissioning, we do have a file that can detail all valid nodes in the network, and the Pantheon client will restrict its communications to just nodes mentioned in that file. On-chain permissioning gets a bit more complicated. It's not a local file. It's stored in a smart contract on the chain, but in essence, it's very similar. There will be a list of nodes which are allowed to participate. You just access it through transactions to the network rather than through accessing a local file.
Got it. Next one we have is how do users or accounts authenticate against the node?
They typically don't authenticate. The way Ethereum operates is transactions and communications are signed using a private key, and that private key is considered verification that you have ownership and control of that account. So we use the public side of that private key to identify actions that are being taken by given accounts, to then use those identities in permissioning. I hope that answers your question, Andres. Please ask further if you have more details you require.
Great, we'll keep moving for now. Stefan's question is the config file prone to attack similar to typical files or centralized databases today?
Yes, the config file is prone to attack, much the same as any system today. If the system that you're running your node on is compromised, then you must treat the entire node as compromised. We highly recommend security in depth and setting up firewalls and various security protections to prevent malicious actors from gaining access to the machines that you're running your nodes on.
I think this feeds in perfectly to the final question it looks like we have for now. Does Pantheon have any capabilities to help an admin detect a malicious actor or node, like you were just talking about?
Nothing explicitly at the moment. We have been considering internally different mechanisms for detecting patterns of malicious actors, but there is a number of ways which you could be under attack, which are usually dependent on the business use cases of the chain in question. So it's a non-trivial thing to find a general purpose detection mechanism. But that being said, Pantheon does expose all the methods you would need to investigate the chain to set up your own detection and do things like watch for transactions of a given type, or try and find people who are receiving abnormal amounts of Ethereum.
Yeah, and just to add a little bit on that, Chris, the other thing that we have in Pantheon is that we have our metrics system. So basically, you can collect data on the number of transactions that are being rejected or connections that are being rejected and things like that, and it might indicate when someone's trying to do something that they are not allowed to or something like that. And again, depending on how you set up your system, you can have some alarms set based on those metrics. Just as an example.
Final question, Chris. We can move on. Are the local config files encrypted or plain text?
The local config files are plain text, though we highly recommend using servers that provide the ability to have encryption at rest to try and protect yourself from any attack. The details that are in the local config files, the lists of nodes that are allowed to participate and accounts that are allowed to participate, is not something that we consider particularly sensitive information. These are lists of public keys. They don't allow for exploiting of accounts. And lists of who's allowed to participate in the network isn't going to expose the identity of your users either. It just exposes the public key that is used to verify the transactions that they might be committing into the network, or the identity of the nodes that try to connect to the network. So we haven't made the effort to make them encrypted yet and don't consider it particularly important, but we would welcome any use case that's identified around that.
Great, let's keep moving and we'll take the next round of questions at the end of the next section.
Great. Okay, talking a bit more about on-chain permissioning and the form of the contracts. Recently in version 3 of the client specification, the Enterprise Ethereum Alliance advertised a specification for on-chain permissioning. And this provides an interface for what the contracts must look like for a client to be able to query them for details about which nodes are allowed to connect and which accounts are allowed to transact on the network and how those accounts are allowed to transact. And it also details how a client must, when a client must utilize these checks, where in the life cycle of a transaction, and where when a connection is established, they must refer back to these contracts for details. So while this specification details how to check a node or how to check a given transaction, it doesn't define how to store the permissioning rules, how you might alter them, what administration functions are available. All those are left to the design of the chain operators. It's an extremely flexible specification that allows for any number of customizations while still allowing for multiple clients to be able to interface with the permissioning solution that you develop, and still allows you to then have homogeneous networks of multiple client implementations. So a given network operator, depending on their requirements, could create a completely custom solution that works as they require and meets their business use cases, and that can be developed by the chain operators or by an engineering department such as ourselves. Or there's also off-the-shelf solutions that are EEA compliant, like our solution. So we'll look a little bit at what our solution currently involves. And the PegaSys on-chain permissioning solution is a set of contracts that provides whitelisting of accounts and nodes that are allowed to participate on the network. The rule system at the moment is fairly simple and being developed into more complex features in the future. But for the moment, it's just whitelisting of accounts and nodes, creating a permitted set of participants in the network. The rules definitions are protected by a list of administrators, which is currently just a simple list without any protections such as voting or organizational quorum management. And to ease use of this solution, we've created a convenient DApp that allows for maintenance of the permissioning solution without having to be an Ethereum engineer or be aware of the underlying mechanisms at use. Later on in the presentation, I'll go into our roadmap and what features we're going to introduce in the future that are going to be useful to customers and enterprises that want to employ this. But before we go any further, is there any questions about the form of those contracts?
Chris, we have one question about if our permissioning features how Facebook's new Libra works. I'm not sure any of us have done enough research to speak to it.
Yeah, I'm not familiar at all with how Libra is setting up their permission network. I know they do advertise it as permissioned blockchain. I am unaware of the implications of that. It could be something completely different from what we're discussing and provide a completely different set of features. It could be related simply to how blocks are being created, that they're being created by a permission set of validators using their BFT consensus mechanism, but I would require a lot more investigation to figure that out.
Looks like we don't have any other questions, so I think we're free to keep moving. Oh, never mind. Hold on. Let's see. Andres had one quick question. Only ETH send raw transaction is signed by the account. How can Pantheon prevent access of an ETH call to an account or any non-signed transaction?
Pantheon doesn't allow transactions to be submitted that are unsigned. Pantheon does not act as an account management tool, unlike Geth or Parity for that matter. Both Geth and Parity allow for account management and wallet management inside of the client. Pantheon does not. Pantheon acts as a transaction relay and blockchain processor. We do have another product that we're working on that acts as the account management and provides calls such as send transaction and allows for account management. But where with Geth, when you call a function like send transaction, it uses an account identity that is stored inside the node to then sign the transaction and send it forward. But like I said, Pantheon does not provide that natively. So every transaction that does get addressed to Pantheon already has an account identity against it.
Yeah, and just one more thing is the question also mentions ETH call. So one concept that is important to remember here is when we talk about account permissioning, we are talking about, you know, what accounts are allowed to execute transactions that eventually are going to modify the state and things like that in your blockchain. So it has nothing to do with who can read data or anything like that. If you a couple of slides back, Chris was talking about the differences between permissioning and privacy and things like that. So just to clarify the concept here, so if you have your node with JSON RPC exposed, you don't have to be authorized in your as an account permissioning to be able to execute an ETH call, for example. Does that make sense? I think I could clarify Andrew's question.
Yeah, to clarify a little more, view transactions are not checked by permissioning because they do not have an impact on the chain and do not alter the ledger.
Yeah, and Andreas just added a follow-up. So basically, permissioning is on writing on the chain and not reading. In terms of account permissioning, basically that would be how you could summarize it.
Yeah, to delve into that a little further, when you're writing the chain, there's evidence that it happened and something that other nodes can validate. If you're just reading, then there's no evidence that it occurred. A singular node can facilitate that, and because permissioning comes about as a network of trust, a single malicious node could expose all of the reading of the chain without any other participant of the network realizing that it's happening. So permissioning does not cover reading at all because we cannot enforce it correctly. But we can enforce writing the chain because evidence is recorded of the effect happening, and we can treat those as violations of the chain's rules.
Great answers, guys. We have actually a couple more. Does this make a use of sidechains, or is this all directly on the ETH chain?
This is all directly on the ETH chain. Sidechains is a completely unrelated feature.
And finally, does permissioning only apply to validators?
No, permissioning can apply to every node of the network. When you're doing account-based permissioning, you might start rejecting transactions that are submitted to your node rather than even relaying them onto validators and rejecting them at the edges of the network. And there's no reason at all why you can't use permissioning in the proof of work network as well, so long as all the nodes are abiding by permissioning. In a network that doesn't have a concept of validators, permissioning still works because all the other nodes on the network will be validating those blocks are correct and checking the permissioning rules are being applied to the new blocks.
Great. I think we're now ready to keep moving. Thanks, guys.
Brilliant. So for the next section of the presentation, I'm going to hand over to Lucas, who's going to do a demonstration of our permissioning solution. He's going to show us how we can use it to restrict access to the network for nodes that are having an impact on the chain, and how we can restrict accounts that can submit transactions.
Okay, thank you, Chris. What we want to show you today is a preview of our on-chain permissioning management solution and how the network reacts to those rules. We've been working in this tool that's going to make it easy to anyone to see the active permissioning rules in the network, manage them, and I think one of the goals is actually to make it really easy so you don't have to be a protocol engineer or a software developer to actually interact with the rules and manage the network, right? One important thing here is that we won't go through the details of deploying the solution, but don't worry because we're gonna, after the webinar, you're gonna receive the materials, and as part of that, you're gonna get like all the instructions that you need to get started so you can play with it yourself, set it up small network so you can learn a bit more of how the solution works and everything. So hope you guys are excited, and let's get started. Where's the share button? There you go. So I'm gonna share my screen here, and I hope you guys can see what's going on in my screen. So what we have here, so right now I have 3 Pantheon nodes running, and they both have accounts and permissioning enabled. So beforehand, I've created all the rules that we need to make sure that the nodes can talk to each other. So the node permissioning rules are all set so they can talk to each other. And I've also created some account rules where I have accounts that can submit transactions to the network. And we're going to see how this behaves in a moment. Let's take a look at the DApp that we are working on. So I hope everyone can see. I don't know if it's too small. So this is how our permissioning management DApp looks like. So because all our rules are stored on-chain, the easiest way to interact with those rules will be through a DApp. So this is what we've been working on, this DApp. Just one quick note here, for those that aren't familiar with dApps, I'm using MetaMask as my wallet. So in MetaMask, I have a set of different accounts that I can use to interact with my application. So I can act as different users. So for example, this is Lucas, the admin account. So the network administrator account. I also have like a couple of other accounts here, like Chris's account. That is one of the accounts that are whitelisted. So I can show you guys how this works. Okay, so let's just take a quick look at our DApp here. This is the admin tab. So as Chris was saying, the admin's accounts are all the accounts that can actually manage permissioning rules. So any admin account is able to promote other accounts to admin. So you can add and remove new admins. You can create new node permissioning rules. So you allow new nodes in your network, or you remove nodes from the network. And the same thing for whitelisted accounts, where you can, add new accounts that can submit transactions to your network. So basically, the admin, super powerful, can do pretty much anything in your system. Here to the right, we have the whitelisted nodes tab. So here we can see all the nodes that are allowed to join your network and establish communication with the other nodes. So right here, we can see that we have 3 different rules, and they match the 3 nodes that I have running in the background. So pretty much what I'm saying is these guys can talk to each other and establish a network. A quick thing, if you're not familiar with eNode URL, so basically eNode URL is the way that we represent a node in the network. It's a URL composed by the node ID, the host, and the port. You probably, if you ever played with Ethereum and started a node yourself, you remember how you have the boot nodes configuration. Usually you would use eNode URLs to represent your boot nodes. So we are using the same format here to specify the rules, how you can whitelist nodes. And to the left here, we have our whitelisted accounts. Again, it's a list with the accounts that can execute transactions in your network, can transfer value, can deploy contracts, and things like that. We have 2 whitelisted accounts here. One is my own account, Lucas the admin, and the other one is Chris's account. That is the one that we're gonna use later during a demo to execute some transactions. Okay, let's start with our node whitelist. Just a real quick example of how this can work. So imagine that we have this consortium network with 3 parties, and each party is represented by one of our nodes. One day, I get an email saying that one of the parties has decided to, leave the consortium network and hasn't signed the renewal. So, without permissioning, we will probably need to do something, in every node that we have, change the firewall rules in the server to make sure that we don't allow connections from that or from that node anymore, or things like that. But with nodes permissioning, basically what we can do, we can just remove the rule that allows a specific node to join the network. So for example, we have this node here. I'm just gonna remove this rule. And what this means, real quick, there you go, it's been processed. So what this means is that one of my nodes, this one at the bottom here, won't be able to talk to any other nodes. Basically, with one click, I'm telling all the nodes in my network, hey, just ignore this guy. He's not part of the network anymore. So we can see that the logs are pretty much saying, hey, no sync target, I'm waiting for peers because the node doesn't have any peers. And on the other 2 nodes, the network's just going on as expected, which is really cool, makes it really, really easy. So again, later on the day, I get another email saying, hey, you know what? They've changed their mind and they want to join the network again. Because yeah, that's how people work. So we can just go back here and create a new rule. Just a reminder, I'm using the eNode URL format here. So the node ID, the host, and the port to identify the node. I'm gonna add this, create this rule again. And what is happening here is I'm saying, hey, all my nodes in the network, you guys can talk to this guy again. So it doesn't matter if you have 2 nodes, 3 nodes or 1,000 nodes, with one click, you can pretty much leverage all this to all the nodes. So I'm just waiting a bit here. Let's see if the node's gonna pick up and connect to the other nodes. It can take a while until the node decides to reach out again. And hopefully this is gonna, and there you go. So we can see that the node is back online. It's talking to other nodes and has already finished syncing. And again, join the network. It's part of the network, and everything is as it was before with a single click, which is really cool. We didn't need to touch any firewalls or anything, which is really cool. Let me go back to our DApp now, and let me show you a bit about account permissioning. So again, we have our list of accounts here that can submit transactions. So what I'm gonna do, I will change MetaMask, and I will use Chris's account. So Chris has got a lot of Ether. He's a really rich guy. And as you can see, Sally doesn't have anything. So why don't we go, just to make sure that things are working, because Chris is in my whitelist, he's able to submit transactions, right? So the simplest transaction that we can send is transferring some Ether. So I'm just gonna transfer Ether to Sally. Yep, confirm. Transaction is pending, and soon it's gonna be confirmed. Perfect. So right now, Sally has got 1 Ether, as you guys can see here. I don't know if it's too small. So now imagine the following scenario. I'm gonna change back to Lucas, the admin here. So I'm there sitting at my desk, and then I got a call from Chris saying, hey, Lucas, I don't know what to do. Someone stole my laptop, and unfortunately, I had my private key stored in my hard drive, and it wasn't encrypted or anything like that. So as an admin, first I'll probably, take a deep breath and say, okay, Chris, it's not a good practice to store your private key unencrypted and etc. But I don't have to freak out, because all I have to do is to come here and say, well, we have this rule that allows Chris's account to submit transactions to the network. So anyone with that has got access to his private key can submit transactions on his behalf. So what I'm gonna do, I will delete this rule. So again, basically, what I'm saying is to all the nodes in the network, just ignore transactions from this sender. And there you go. That's what just happened. So when the thief tries to use Chris's account, so I'm changing back to Chris's account here, to steal all his Ether. So again, let's demonstrate it here. So Chris is transferring everything to the thief, all his money, right? So I'm going to submit this transaction. We can see that the transaction is sitting there in a pending state. And I just want to quickly go back to the logs and show what's going on in one of our nodes here. There you go. We can see that the node is giving you those alerts saying, hey, I've got this transaction here, but it's from an invalid sender, and I'm not going to do anything with it. So the transaction is going to sit here in the pool for a while, and eventually it's going to be discarded, as we would expect, because Chris is not in the whitelist anymore. And the cool thing is that this applies to any node in the network. So here I'm interacting with this node, but any node in the network now is they are all following the same rules, again, with just one click. I think that's what I wanted to show you guys here. I hope you guys enjoyed this demo, and we're really keen to let you guys play with it at home and let us know what you think. I'm happy to take any questions if you guys have any.
Starting off, we have a question from Stefan. Can a whitelisted node potentially be spoofed?
A whitelisted node potentially be spoofed?
No. Whitelisted nodes can't be spoofed, but the node's identity can be stolen. All communications which occur on the Ethereum network are signed by a private key, and that private key, holding of that private key, acts as verification of your identity. If that private key is stolen, yes, you can act as a given node. You can install yourself on the network and send transactions that secure that node. But hopefully, the administrators of that node detect that their key has been stolen, there's been an intrusion into their system. But as far as spoofing goes, there is a whole bunch of math that is a tiny bit beyond me that shows that it isn't practical to try and replicate these keys given the public identity.
Good answers, guys. Good questions. Next one, can you elaborate a little bit on what's happening behind the scenes when an admin removes a node from the whitelist?
Yep. When a node is removed from the whitelist, all well-behaved nodes see the transaction enter into the chain and see that the contract has been updated. They then audit their outstanding connections, look for any that no longer are allowed according to the rules, and disconnect any nodes which are no longer in the rules. So where Lucas demonstrated that one of his nodes was disconnected and no longer had any peers, what happened was the two other nodes saw the new block appear with the new rule and terminated their connection to the node that was no longer permitted. And the node that was no longer permitted did not end up receiving the block that contained the rule change. So the node that is disconnected isn't responsible for disconnecting itself. The well-behaved nodes in the network that are still permitted are responsible for disconnecting nodes that shouldn't be allowed to be there. And when a new connection is established, the rules are checked again there to make sure that the new connection should be allowed to be established or the new connection should be denied.
The quick follow-up for that is, so an admin is implicitly trusted by all of the nodes?
No, an admin is allowed to edit the rules stored inside the contract. And that is not explicitly it's not explicitly an endorsement of trust. It's entirely possible to create a permissioning contract that does not contain admins at all and has an open register of rules that anyone could change. Admins don't play into whether or not the permissioning rule is to be trusted or not, just whether or not the rule is present inside the contract.
We're going to take a couple more and then I might jump a few to the end of the presentation because I know we're coming close on time. First one is, when is the transaction discarded from the transaction pool after being blocked?
Transaction is discarded from the transaction pool at our standard transaction pool pruning time, which is either when the transaction pool is full, which you are unlikely to reach on modern hardware, or about 13 hours after it's been submitted. It is maintained in the transaction pool up until that point. If the rules change while it's in the transaction pool to then allow the transaction will be processed. So you can imagine it being stored in the transaction pool for the same lifetime as a transaction with an incorrect nonce.
And let's do one more, and then I'm going to defer the rest of them. Is there a recommended minimum number of nodes to have whitelisted?
Not really. It matches the number of nodes which is recommended to have in your network, which is completely dependent on your business use case. If you are using something like IBFT2 to control your network, then your minimum should be about 3 in the whitelist to maintain the validator pool. If you have a much wider network, then your minimum should be the wider network. There is nothing stopping you from having a whitelist of one node and that one node being your miner producing blocks. That is an operable scenario, but not exactly useful in an Ethereum context.
Great, let's keep moving, Chris, and we'll answer some of the remaining questions at the end in just a few minutes.
Great. That's the right one. So that was the demo that shows us some of what we've developed so far, and we have a lot of new features coming in the future to make this a more robust solution and address more business use cases. So let's look a bit at the roadmap going in the future. Where we stand currently, in the Pantheon 1.1 release, the on-chain permissioning is installed inside Pantheon. It's got the capacity to address the contracts which have been created. In our next release of Pantheon, that's coming at the end of July, we'll be releasing the management application that you just saw and the accompanying contracts in a production-ready state. That being said, they're available today in our open source repos in a pre-release state, and you're very welcome to come and investigate them and try them out and give us some feedback, because of course we love feedback and any suggestions that you might have, or if you want to participate in the project, you're welcome to as well. Moving further into the future, in our October release, we're going to be adding groups and roles for rules management to make it easier to maintain the gigantic networks, which I'm sure you're all maintaining and facilitating your enterprise use cases. And moving even further into the future, in our 1.4 release, we're going to be installing granular transaction permissioning which will allow you to define restrictions on which account, not just which accounts might participate in the network, but which accounts are allowed to talk to other accounts and do things like restricting contract access and restricting the amount of value that can be transferred, and some more complex permissioning scenarios that I described earlier on in the presentation. And we'll be installing groups and roles for administration, which will allow things like the installation of super users for a given group of participants in the network, so that in a consortium of enterprises, you could have an administrator who can freely add users to a consortium's group, rather than having to achieve shared buy-in from the rest of the network. So that's the roadmap that we currently have put together and the features that we currently have planned. And that brings us to the end of the presentation we've got planned. Before we jump into the Q&A sessions, we've got a link for a feedback form if you have any suggestions about the webinar or any feedback you'd like to deliver to us, or if you just want to tell us that you enjoyed it. We recently launched a certification program for Pantheon, which is, first of all, a great way to learn about Pantheon and an even better way to demonstrate that you're an expert with our tools. So please do check that out if you're interested. And if you're interested in contributing to Pantheon, we've dropped in chat a link to our introductory board of good first issues for you to participate on. We're an open source project that welcomes all contributors to come and join us in our journey. You're very welcome to come and play around with the client, add new code, make suggestions. Beyond that board, we're available on Gitter 24 hours a day, and I'm very happy to engage with the community. So thank you very much for coming along to the presentation today, and I hope you've enjoyed it. I hope it's been valuable. We'll jump into the Q&A time now and address the final sets of questions. Thank you.
We'll give everyone a minute. Looks like Lucas answered the ones that were outstanding from the last bunch. So we'll see if anyone adds any to the chat. Mm-hmm.
I've just been told that the URL that we've got for the certification course is slightly incorrect. I've just pasted the correct one into chat. Or I'm about to paste it into chat.
All right, first question we have, and thank you for whoever called that out. Any intention of exposing the permissions controls through JSON RPC?
For the local permissioning, yes, they're already exposed through the JSON RPC. For the on-chain permissioning, given that Pantheon does not act as an account management and a wallet management tool, it doesn't make a great deal of sense for the JSON RPC to expose the permissioning controls. For two reasons. The first one being that the administrator identities shouldn't be locked down to a given node. They should be stored separately to the nodes and distributed amongst your administrators as hardware wallets or through another account management tool, so that they can create transactions and talk to any node and send those commands back into the permissioning engine. And the second reason is that we aren't trying to restrict what administration functions are available. While we have the solution that we're shipping for permissioning, there's no reason why any chain out there isn't going to come up with their own custom administrative method that may act in a completely different way, that has a completely different set of administrative functions that we don't want to restrict through our JSON RPC. So we would expect that when a chain decides to do a custom solution, they will produce their own method of management, such as a different DApp.
Yeah. And if you think about on-chain permissioning, behind the scenes, everything that the DApp is doing is sending transactions to the chain. So again, so you can if you have your own solution, script or anything that's gonna submit a signed transaction to a node and change your rules if you're an admin.
Any final questions? All right, I think, oh, we have one more. All these transactions are committed to Ethereum mainnet, question mark?
All the transactions that go to the permissioning contracts are committed to whatever chain you're talking to. So permissioning itself is not well suited to mainnet. Mainnet is designed to be an open, permitted network that does not have any restrictions. But on your private chains, where you can install permissioning widely across all of the nodes, yes, all of the transactions that update the smart contracts are transactions in the traditional Ethereum sense and are stored in the ledger.
Last call. Going once, going twice. All right, I think we're in the clear, guys. Thank you everyone for attending. And again, please fill out those forms. We'd love your feedback and we'll be sending all the materials afterwards.
Thank you, everyone.
Thank you everyone for attending. And if you have any further questions that occur in the future, do reach out to us on GitHub or via any of our communication channels. We'll be more than happy to engage with you.